Everybody, and once again welcome to Pankaj Sir's Echelon tutorials. In this today's session, in this today's video, I'm going to I'm going to discuss about a curriculum called IBDP, and the subject is again physics. Level is 11th grade, and the book that I will be referring to is a book written by K.A.TSOKOS, and this is the 6th edition book that I am using. Let me inform you that there is the 7th edition book of this particular author also available, but I am referring to the 6th edition because the topic that I have covered in this particular video, or I am going to cover in this particular video, are there in the 6th edition, not in the 7th edition, right? So once again, welcome to my Echelon tutorials, and curriculum is IBDP, subject is physics, and the level is 11th grade. Okay. So in this particular book, in this particular curriculum, okay, the very first chapter, okay, is related to these things that I'm going to discuss with you. Okay, these are some elementary physics stuff. Okay, where the elementary knowledge of mathematics, elementary, knowledge of the mathematics and physics. You know how you have to club them. That has been discussed in this particular chapter. To talk in short, okay, there'll be something called order of magnitude that I'll be discussing, and I'll be discussing the various units in physics and the fundamental quantities in the physics that are being used. Okay, this is very elementary physics, but then if you want to take a dip into the physics higher level, okay, you have to go through all these elementary things. These are the prerequisite knowledge, okay, that one should have before taking a dip into physics, right? So let us get started with, and let us talk about the order of the magnitude first. What is the meaning of order of magnitude? Now, order implies power of 10. Okay, so anything expressed in the form of power of 10, say power 10 is to 2, 10 is to 1, 10 is to minus 5, 10 is to 100. All this implies power of 10. Okay, so order implies nothing but power of 10. Nearest value obtained in power of 10 is called the order of magnitude. Okay, so what is order of magnitude? It is the nearest value obtained in the power of 10. Okay, now what is the meaning of nearest value? That we'll discuss now. Now, any number, there's something called scientific notation. Okay, so in scientific notation, any number can be expressed in the form of n into 10 raised to x. Okay, this is a format, or this is the way scientific notation may a number can be written, n into 10 raised to x, where you can say this n is something which is always between 1 and 10. Okay, that I have not written here, but let me write that. N is always between 1 and 10. Okay, it should be less than 10, it should be greater than 1. Okay, and one more thing, this x, is a positive or a negative integer. This is the requirement for a number to be in scientific notation. So n should be between 1 and 10, and x, that is the power of the 10, should be either a positive or a negative integer. Okay, now let us try to understand this particular statement. Distance of earth from the sun is, okay, 1.49 into 10 raised to 11 meter. Now this is an established fact. They are telling you that the distance between the earth and the sun is 1.49 into 10 raised to 11 meter. Okay, now this can also be written as 1.49 into 10 raised to 8 kilometers. Okay, both the statements are correct. Why? Because 1000 meter will make 1 kilometer. Okay, so if you convert this meter into kilometer, you will have to convert only this order part. Okay, that is 10 raised to something that you have to convert. Okay, so 10 raised to 11 meter, if you convert it into kilometer, it will be 10 raised to 8 kilometer, right? So the distance of the earth from the sun is 1.49 into 10 raised to 11 meter, or 1.49 into 10 raised to 8 kilometer. Both are correct. Now if such a statement comes in front of you, what is the order of the magnitude of this particular distance? Okay, the answer will be the order of the magnitude of this particular distance can be written as either 10 raised to 11 meter, or it can be written as 10 raised to 8 kilometer. Okay, now this is the meaning of order of magnitude. So order of magnitude of a distance between the earth and the sun is of the order 10 raised to 11 meter, or you can say 10 raised to 8 kilometer. Both the answers are correct. Now, here what you have to pay attention to is this number 1.49 into 10 raised to 11 meter is of the form n into 10 raised to x. That is the scientific notation, isn't it? And in this particular scientific notation, the number 1.49, that is your n equal to 1.49, is less than equal to root of 10. Okay, root of 10 is 3.16. So you see that 1.49, this n part of the scientific notation, that is less than 3.16. Okay, so if your n in any number, okay, if any scientific notation number, if n is less than or equal to 3.16, then the order of that particular, the order of magnitude of that particular value of that particular property, okay, in this case it is the distance, then the order of the magnitude will be 10 is to x itself. So here in this case, this number is in the form of 1.49 into 10 is to 11 meter, and 1.49 is less than or equal to 3.16. Therefore, the order will be 10 is to 11 meter, or it can be written as 10 is to 8 kilometer as well, because when you write 10 is to 8 kilometer as the order of the magnitude, then also it is okay, because this 1.49 in both the cases remains less than or equal to 3.16. So this particular thing is very important. That is, if n is equal to, if n is less than or equal to 3.16, then whatever 10 is to x is the order, okay, this will be the order of magnitude, right? So I've written here, therefore 10 is to x is the nearest value of the order of magnitude. Now this is the nearest value. This is the meaning of nearest value. Okay. So let us go to the second example. Suppose mass of one electron is given as 9.1 into 10 raised to minus 31 kg. Okay. Now here also the mass of the electron, one electron, is given in the scientific notation, right? 9.1 into 10 raised to minus 31 kg is nothing but of the form n into, this is of the form n into 10 raised to x, isn't it? Now n should be between 1 and 10, and obviously here you can see it is between 1 and 10. So this is scientific notation, right? And you have 10 raised to x, and x has to be either a positive or negative integer. In this case, it is a negative integer. Well, so the definition of a scientific notation number is satisfied over here. N should be between 1 and 10, and x should be either a positive or a negative integer. So this definition is satisfied. So we can say that it is in the scientific notation. See, let me tell you, if a number is not in scientific notation, somehow you will have to bring it in scientific notation, then only you can decide the order of magnitude. Now that is very important. Okay, so it is not that always the number will be given you in the scientific notation form. If it is not in the scientific notation form, what I mean to say is this n, if it is say more than 10, okay, or if it is less than 1, then you have to do something about it and bring it in the scientific notation form, and then only you can decide the order of magnitude. So here you can see that it is already in the scientific notation form. Now next step is to check whether your n is greater than, less than or equal to 3.16 or not. Okay. Now here you can see that your n, that is your 9.1, is greater than root 10. Okay. It is greater than root 10, or 9.1 is greater than 3.16, right? And if that is the case, if your n is greater than 3.16, then the order of the magnitude, the nearest order of the magnitude will be 10 raised to x plus 1, not 10 raised to x. It will be 10 raised to x plus 1. So in this case, your order, nearest order of magnitude will be 10 raised to minus 31 plus 1. And minus 31 plus 1 is minus 30. So the nearest order of magnitude is minus 10 raised to minus 30 kg. Okay. So you will understand from this how the order of the magnitude is decided. Okay. So the nearest value obtained in the power of 10 is something which is tricky. Okay. You have seen in the first case, the nearest value obtained in the power of 10, okay, was 1.49, which was less than 3.16. And here it was 9.1, which was greater than 3.16. So when it is less than 3.16, you have to take 10 as to x as the order of magnitude. And if it is greater than 3.16, then you have to take 10 raised to x plus 1 as the order of magnitude. So these are the things you should remember well to get an answer of the order of magnitude. Now let us proceed and go for some few more examples. Now the third example you can see over here on the screen, that is age of the universe is given as 5 into 10 raised to 17 seconds. What is the age of the universe? 5 into 10 raised to 17 seconds. Now this is of course of the form n into 10 raised to x, that is the scientific notation form. Why? Because your n is well between 1 and 10, it is 5, and your x is an positive integer which is 17. Okay, so this is in a scientific notation. I have written here n is between 1 and 10 and x is an integer not equal to 0. It can be either positive or negative integer but not equal to 0, and that condition is satisfied. Now let us check whether this n, that is 5, is greater than 3.16 or less than or equal to 3.16. And looking at it, it is very clear that 5 is greater than 3.16. So whenever n is greater than 3.16, what will be the order of the magnitude? The order of the magnitude will be 10 raised to x plus 1. So here it is 10 raised to 17. So your order will be 10 raised to 17 plus 1. So it will be 10 raised to 18 seconds. Okay. So the order of magnitude in this case is 10 raised to 18 seconds. Right. Next example is in 2.2 into 10 raised to 2. What is the order of magnitude? The order of magnitude is 10 raised to 2 units. Now here 2.2 into 10 raised to 2. I have not mentioned anything in front of it. Okay, I have not mentioned whether it is kg, meter, whatever. Okay, so no units has been mentioned. So order of the magnitude will be whatever units this number is in. So if this is 2.2 into 10 raised to 2 meter, then the order of the magnitude will be 10 square meter. If it is 2.2 into 10 raised to 2 kilometer, then the order of magnitude is 10 raised to 2 kilometer. So in general, I have written units over here. Okay. So the order of this particular, the order of magnitude of this particular number is 10 raised to 2 units. Why? Because this n, that is 2.2, is less than or equal to 3.16. Therefore, order will be 10 raised to 2. Here in this number 4.5 into 10 raised to 2, again the order of the magnitude will be 10 raised to 3 units. Now why 10 raised to 3 units? Because this 4.50, here n, is greater than 3.16. And whenever n is greater than 3.16, the order of the magnitude will be 10 raised to x plus 1. So here 10 raised to x is 10 raised to 2. So you will have to write the order of magnitude as 10 raised to 3, x plus 1. Okay. Now, in this case, 3.25 into 10 raised to minus 3. Okay, in this also, the order of magnitude will be how much? Check this 3.1, 3.25. Now, 3.25 is greater than 3.16, isn't it? It is greater than 3.16. Therefore, the order of the magnitude will be 10 raised to minus 3 plus 1. And if you do that, you will get the order as 10 raised to minus 2. So I hope you have understood what is the meaning of order of magnitude. You must have understood how to determine the order of magnitude. You must have also understood what is a number in scientific notation. So you have to take care of so many things. First of all, any number should be in the form of a scientific notation. Then you have to check whether that n part of that scientific notation is less than equal to 3.16 or it is greater than 3.16. If it is less than equal to 3.16, then into 10 raised to x will itself be the order of the magnitude. And if n is greater than 3.16, then 10 raised to x plus 1 will be the order of magnitude. So let us proceed now. What is the order of magnitude of, now this is a very intelligent question. What is the order of magnitude of number of molecules of hydrogen gas in the sun? and they have given us the information as mass of the sun is 10 raised to 30 kg. Okay, and assume that the sun is made up of hydrogen gas only. Okay, so in this question, it's a tricky one, but I'll make you understand and we'll get to the answer. Okay, in this question, you have to assume that the sun is of the mass 10 raised to 30 kg. So mass of the sun is how much? 10 raised to 30 kg. Now 10 raised to 30 kg is a very, very huge number. Okay, don't just look at the size of the number that is written over here. Okay, 10 raised to 30 means 10 and then 29 more zeros. Okay, that many kg. So it's a very, very huge number. So 10 raised to 30 kg is the mass of the sun, and he is telling you that sun is made up of hydrogen gas only. So this 10 raised to 30 kg is the mass of the hydrogen gas. Sun is completely made up of hydrogen gas. Okay. Now they have asked you to find out the order of the magnitude of number of molecules of the hydrogen gas. So we are first supposed to find out the number of molecules of the hydrogen gas, that too in the scientific notation form, isn't it? So let us try to do that. Number of molecules of the hydrogen gas, how you will find out. Now, in this particular question, no, you should have a little knowledge of mole concept. There is something called mole concept. Now, this mole concept, okay, everybody must have studied in your 10th grade. Okay, in IGCSE in the 10th grade, you have studied this mole concept in chemistry, I suppose, right? So mole concept is what? In this mole concept, there is a formula called N equal to mass in grams upon the molar mass of a substance. Okay. Now, this N is number of moles, right? So this formula we are going to make use of. Okay. So mass of the sun is 10 raised to 30 kg. Now in this formula you can see number of moles N is equal to mass in gram. So we need the mass in grams, not in kg. So what I'll do, this mass of the sun, which is 10 raised to 30 kg, I'll convert it into gram. So it will be 10 raised to 33 grams. So this is that mass I'm interested in. Okay. Now, because the sun is made up of entirely hydrogen gas only, so you can say this 10 raised to 33 gram is nothing but the mass of the hydrogen gas, isn't it? So, number of N is the number of moles of hydrogen gas equal to mass in grams of this hydrogen gas is how much? 10 raised to 33 grams, divided by what is the molar mass of the substance. Now substance is what? Hydrogen gas. What is the molar mass of hydrogen? See, molar mass is nothing but number of protons and neutrons in a hydrogen molecule. Okay, so in a hydrogen molecule, or rather in a hydrogen atom, the number of this thing, molar mass of hydrogen will be 2 grams. Okay, right, because it has one proton and one zero neutron. Okay, see, one hydrogen atom, okay, one hydrogen atom has this is one hydrogen atom, right? You have two hydrogen atom in a molecule, right? Hydrogen molecule may you have two atoms, right? So in one atom you have one proton and zero neutron. In another atom also you'll have one proton and zero neutron. Okay, molar mass is this mass, proton plus neutron. So 1 plus 0 will be 1, and here also 1 plus 0 will be 1, and this 1 plus 1 will be 2. So molar mass of hydrogen gas is 2, and expressed in grams it will be 2 grams. Is that understood? So your N, that is the number of moles of hydrogen gas, will be given by 10 is to 33 grams upon 2 grams. This Gg gets cancelled, and 10 is to 33 upon 2, here I've done it, okay, for you. 10 is to 33 upon 2 is nothing but 5 into 10 is to 32. Okay, and here you will write MOL. MOL is the unit for mole. Okay, or you can say mole is written in short form as MOL. So you have calculated the number of moles of hydrogen gas in the sun. Okay, but we are not asked to find out the order of magnitude of the number of moles. We are asked to find out the order of magnitude of the number of molecules. Now don't get confused with this number of moles and number of molecules. Number of moles you got as 5 into 10 raised to 32. Okay. You have not got the number of molecules. Now, to get the number of molecules, you will have to use this relationship. 1 mole of hydrogen gas or any gas, okay, has 6 into 10 raised to 23 molecules of that particular gas. Okay. So this is also there in your IGCSE 10th standard curriculum. 1 mole of any gas has 6 into 10 raised to 23 molecules of that gas. Now, we have found that in the sun, there is 5 into 10 raised to 32 moles. Okay. So, in this much moles of hydrogen gas, how many molecules will be there? So, in 1 mole of hydrogen gas, when there is 6 into 10 raised to 23 molecules, therefore, in 5 into 10 raised to 32 moles of hydrogen gas, how many molecules will be there? You will have to multiply these two. So, the number of molecules will be 5 into 10 raised to 32 multiplied by 6 into 10 raised to 23. So, this will be your answer. This is the answer for number of molecules. This is number of molecules of hydrogen gas in the entire sum. So this number you get as 6 into 5 is 30. 30 into 10 raised to 32 into 10 raised to 23. So it will be 3 into 10 raised to 32 plus 23 plus 1. That works out to 3 into 10 raised to 56. So in the scientific notation, now you have got the number of molecules, number of hydrogen molecules in the sun. So how many molecules are there in the sun? The number of molecules in the sun is 3 into 10 raised to 56. Now from this, and it is in the scientific notation form, because this is of the form n into 10 raised to x, where n is between 1 and 10. It is 3, so it is between 1 and 10. And your x has to be either a positive or a negative integer. It is 56, so it is a positive integer. So this is a scientific notation form. Now, to find the order of magnitude, what you will have to do is you will have to find the nearest value of the power of 10. Now, the nearest value, how we will find out? We have to take this n and check whether this n is less than or equal to 3.16 or whether it is greater than. Now, 3 is well below 3.16. It is less than or equal to 3.16. Therefore, whatever is 10 raised to x, that will be the order. So in this case, your order will be 10 is to 56 only. No need of adding 1. Okay. So 10 is to 56 is the order. Now here you have to write 10 is to 56. What should be the this thing unit? It should be 10 is to 56. Uh, uh, it's a number of molecules, right? So no need of writing any unit. Okay. So the number of molecules, hydrogen molecules in the sun is of the order 10 is to 56. Because it's number, no unit. If it was mass, then you should have written either gram or kg. If it was distance, you should have written as either meter, kilometer, whatever. But this is a pure number, so the order of magnitude will be just 10 is to 56. I hope you understood this order of magnitude ka meaning and how to find out the order of magnitude of this uh, number of molecules in the sun. Okay, number of molecules of hydrogen gas in the sun. Fine. Chalo. Let us proceed. So that was all about order of magnitude. Now let us proceed and move on to something called SI system. Now SI system is a system in which all measurements, are considered, and it is universally accepted by each and every country in the world today. Okay, this was introduced in 1960s, and since then it has been accepted by each and every country of the world. Okay, so SI system is what it has. In this system you have some 7 basic units. Okay, and you have 2 supplementary units, so total 9 units are there. Physical quantities and physical units are 9 in this particular SI system. Let us talk about the 7 basic units first. Okay, so what are the 7 basic units? The first one is meter. Okay, and its symbol is M. and this is for the physical quantity length. Second one is kilogram, and its symbol is kg, and this is the unit for the mass. Third one is seconds, its symbol is s, and this is the unit for time. The physical quantity is time. Fourth one is ampere, its symbol is capital A, and this is the unit for a physical quantity known as electric current. Fifth one is Kelvin. Its symbol is capital K, and this is a unit for a physical quantity called temperature. Okay. This next one, sixth one is mole, M-O-L-E, mole. It is written, its symbol is MOL. Okay. And this is unit for a amount of substance. Okay. The physical quantity is amount of substance. Then the last one, the seventh one is candela. Its symbol is CD, and this is a unit for luminous intensity. Okay, so these are the 7 basic units in SI system. Now, the 2 supplementary units in the book, they have not mentioned anything about these 2 supplementary units, but let me tell you, these 2 supplementary units are: number 1, a plane angle. Okay, and this plane angle ka unit is radians. Okay, and radians is written as RAD. This is the symbol. The second one, the second supplementary unit in SI system is something called solid angle. And solid angle, the unit that solid angle is measured in is steradian. Steradian. Steradian is the unit for solid angle. And the symbol for this steradian is SR. So this, because it is not mentioned in your book, nothing has been mentioned about these 2 supplementary units. But as a student who is aspiring to get a higher knowledge in physics, they should not bother about whether something is given in your book or not. As far as possible, you should try to get the knowledge from other books as well. Okay. So in other books, in other curriculum, they have talked about these 2 supplementary units in the SI system, that is plane angle and the solid angle. Okay. So these totally makes 7 plus 2, 9 units in the SI system. Okay. Now, these 7 units that I talked about right now, not these 2 supplementary units, these 7 units are also referred to as fundamental units. Okay, now these are fundamental units, these 7. Okay, now using these fundamental units, you can make some derived units. So some of the derived units are, say, meter per second. Meter per second is a unit which is written in symbol, which is written as M per S, M for meter and S for second. So this particular unit is for the physical quantity called velocity. Now you all know velocity is a physical quantity whose unit is meter per second. And this unit of meter per second is a derived unit because it is a combination of 2 fundamental units. Okay, it is meter divided by second, right? Same way joule. Joule is a unit for work or energy. Okay, the physical quantity is work or energy, and its unit is joule. Joule is nothing but Newton into meter. Okay, so again, Newton and meter, these are both derived quantity. Newton itself is a derived quantity, and meter is also a fundamental quantity. So this is totally a derived quantity. Joule is a derived quantity. Now Newton is also a derived quantity because Newton is derived from this kg, meter and second raised to minus 2. Newton is the unit of force. Okay. So force is a derived quantity. Its unit is Newton, which is also a derived unit. Right. Now watt, W-A-T-T, whose symbol is W. This is also having a unit as joule per second, or you can say joule s raised to minus 1. This watt is the unit for a physical quantity called power. So these 4 quantities that I have mentioned you here, these are examples of derived units. Why derived units? Because they are made from the fundamental units. Is that clear? Okay, chalo. So you came to know now there are some 7 fundamental units in SI system, and using those fundamental units you can make derived units also. Okay, and apart from that you have 2 supplementary units, plane angle and solid angle. Now let us talk about the multiples of 10 will give you both small and big units. Now when you have a particular unit, okay, and if you multiply that unit by a power of 10, okay, then you will get either bigger unit or smaller unit. So if you multiply by say 10 is to x, and if x is a positive integer, then it will be considered as a bigger unit, and if x is a negative integer, then it will be considered as a smaller unit. I'll give you one example over here. 1 meter is a SI system may unit for length. Okay, it's a standard SI system unit, 1 meter. Now if I write 1 meter multiplied by 10 is to minus 2, this is nothing but 1 centimeter. Okay, this is a smaller unit. And if I write 1 meter multiplied by 10 raised to 3, okay, this is 1 kilometer. Okay, so 1 kilometer is a bigger unit, 1 centimeter is a smaller unit than meter. So compared to 1 meter, 1 centimeter is a smaller unit, and compared to 1 meter, 1 kilometer is a bigger unit. So you can write this way: meter, okay, bigger than meter is kilometer, and smaller than meter is centimeter. This is the order. So centimeter is a smaller unit, usse bada hai meter, usse bada hai kilometer. This way it goes. So whenever you multiply by 10 raised to something like 10 raised to x, okay, and if x is positive, okay, then you say that it is a bigger unit. And if you multiply by 10 raised to x, where x is a negative, okay, in this case minus 2, then it results in a smaller unit. So I hope you have understood what is a bigger unit and what is a smaller unit. Now here I have given you a list of all the possible, you know, bigger and smaller units of length. In the SI system, length is measured in meter. Okay, so 1 meter into 10 raised to 3, when you multiply by 10 raised to 3, 10 raised to 3 will make it a bigger unit. So this 1 kilometer is a bigger unit. So when you multiply by 10 raised to 3, the unit is named as kilometer. 10 raised to 3 stands for kilo. 10 raised to 2 stands for hectare, okay, or hecto, Hecto. Now this is very rarely used, but 10 raised to 2, if you multiply any unit by 10 raised to 2, it will be called as hecto. So since this is meter, we'll call it as hectometer. Now these two are bigger units compared to what? Compared to the meter. Now 1 meter into 10 is to 1. Now 10 is to 1 may be 10 is to 1 will make it a bigger unit. Why? Because this it is multiplied by 10 is to x, where x is a positive integer. Okay, so 10 is to 1 is nothing but 1 decameter. Okay, so DECA, deca, stands for this 10 raised to 1. Anything multiplied by 10 raised to 1 is deca. Okay, and since this is meter, it will be written as decameter, DAM. Deca ka short form is DA. Okay, hecto ka short form is H. Okay, here there should be meter. Okay, kilo ka short form is K. That way. Okay, same way, 1 meter multiply 10 is to minus 1. Now, because it is minus 1, now you will get a smaller unit. Okay. And this 10 is to minus 1 is written called as deci, DECI. And deci is written as only D. Don't get confused. Deca is DA, deca is DA, and deci is only D. Okay. So, decimeter, if you want to write, you will write DM. So, DM means decimeter. Okay, DAM means decameter, right? Decameter is a bigger unit, decimeter is a smaller unit compared to meter, right? Then 10 raised to minus 2 will be called as centi, so 1 centimeter. 10 raised to minus 3 will be called as milli, so 1 mm, 1 millimeter. Then 10 raised to minus 6 is written as micro. This mu is standing for micro. So 1 micrometer will be 1 mu m. Then 10 raised to minus 9 will be nano, 1 nm. This N stands for nano, 1 nanometer. 1 nm is 1 nanometer. It is 1 meter into 10 raised to minus 9. Okay. 1 meter into 10 raised to minus 12 if you do, you will get 1 picometer, pm. And if you do 1 meter into 10 raised to minus 15, you get a femtometer. Okay. 10 raised to minus 15 is femto. So 1 fm is 1 femtometer. Is that clear? So these are all the bigger and the smaller units of length compared to meter. So here still bigger units I have written. Anything when you multiply by 10 is to 6 is read as mega. It is written as capital M. Anything multiplied by 10 is to 9 is giga. The symbol is G, capital G. Anything multiplied by 10 is to 12 is tera. The symbol is T. 10 is to 15, peta. The symbol is P. 10 is to 18, exa. And the symbol is E. So these are all the units and the prefixes that will be used before the unit whenever you write the units. And these are all bigger and smaller units of any quantity. Okay, here I have given you an example of length as a physical quantity. Okay, and these are the units, the bigger as well as the smaller units of length. Okay, now for any physical equation, the units on the left hand side and the right hand side quantities should match. For example, periodic time, T. Okay, it is given by this formula. Okay, T is equal to 2 pi square root of L upon G. Now this L is the length of the pendulum, you can say, and G is the acceleration due to gravity. Okay, acceleration due to gravity. So the unit of periodic time T is seconds, and the unit of the whatever quantity you see on the right hand side should also be second. That is what he says, that in any physical equation the left hand side and the right hand side quantities should have the same unit. The unit should match. Okay, so let us check whether the unit is same. Now time period, the unit is second, it is known. Let us check whether here the unit is second or not. 2 pi is a constant, so constant value will not have any unit. Square root of length is measured in meter, so I'll write meter, upon G. G is acceleration, it is measured in meter per second square. So square root of meter upon meter per second square, if you work out this meter will cut out and you will get square root of second square, and square root of second square is nothing but second. Okay, so you get 2 pi, and the 2 pi is constant, so the right hand side ka unit will be seconds. Okay, so you can see that the unit on the left hand side and the right hand side are both matching. Okay, let us take one more example. Force. Force ka formula is force is equal to m into a. The unit of force is Newton, and Newton is a derived unit, so it can be written as kg mass second raised to minus 2. This is the unit for force. Now in this physical equation on the right hand side you have m into a. So m into a ka unit will be what? M ka unit will be kg. M is mass, so unit will be kg. Acceleration ka unit is meter per second square, so it will be m into second square. Second square means you can write m per second square, so you can write m into second raised to minus 2. Now if you check the units on both the side, on the right hand side it is kg meter second raised to minus 2. On the left hand side also it is kg meter second raised to minus 2. So you will see that in any physical equation or in any physical formula, the units on both left hand side and right hand side should be equal. Now this is a test also. Suppose you don't know or you are doubtful about a formula, you just check whether the units on both left hand side and right hand side are equal. If it is equal, then your formula is correct. Otherwise there is some mistake in the formula. Now velocity of a wave in a string, let it be say v. Now here I am trying to make you understand how this works. Okay, that is the unit on both the side has to be same in any formula. Suppose the velocity of a wave in a string, so suppose you have a string and if you pluck that string with some force, okay, then there will be a wave creation in that string, and the velocity of that wave is suppose v. Okay, Now this velocity that is created in the string will be dependent on three quantities. Number one, the length of the string. Number two, the mass of the string. And number three, the tension force of the string. Okay, these are the three things. Now let us say that velocity is equal to some constant k times f raised to x, l raised to y, m raised to z. Now what is this f, l and m? F is nothing but the force, okay, the tension force. L is nothing but the length of the string, and m is nothing but the mass of the string. So F, L and M are the physical quantities on which this velocity of the wave in the string will be dependent. And this powers, x, y and z I have taken. I'm not sure, but the formula is something like this, but I'm not sure what these values of x, y and z are. So if I want to determine the value of x, y and z, what I will do is, to find x, y and z, we must ensure that the units on both the sides of this physical equation or of this formula is same. Now I am very sure that velocity on the left hand side has a unit of meter second raised to 1. Okay, m s raised to minus 1. This is the unit of velocity. I'm sure about that. Now this unit, I will write it in the form of dimensions. Okay, so meter is having a dimension which is L, and this second is a unit which has a dimension which is time. Okay, so when you say dimension, that means the physical quantity. Okay, the fundamental physical quantity, the mass dimension is written as m. Dimension is always written in square bracket. Length is written as L between the square bracket, and time will write as T. So the fundamental quantity, mass, length and time, the dimensions of them can be written as capital M, capital L and capital T. So here this is meter, which is a unit of length, so for that the dimension will be L. For second is the unit of time, so dimension will be T. Okay, so LT. If I want, you can write, you can put this square bracket also. Okay, this way. Okay. So L raised to nothing, I mean 1, and T raised to minus 1. Now, here if you come on to right hand side, you have K as a constant. Okay, so that we are not having any unit. Okay, it is a constant, so no unit. When no unit, no dimension. Let us come to force. Force is what? Force ka dimension is MLT raised to minus 2. Okay, this is the dimension formula of force. Now why MLT raised to minus? Because force is equal to mass into acceleration. So mass is nothing but m. Acceleration is meter per second square. So it is the length and then second square. So second square can be written as t minus 2. And that is why the MLT minus 2. MLT minus 2. And the whole raised to x, because this f is ml minus 2 and f raised to x means the whole thing raised to x. Then L is the length, so I'll write L, okay, capital L raised to y. And this m is not meter, it is mass, isn't it? Mass of the string. So I'll write here capital M raised to z. So I hope you understood this. Now comparing the index or the exponents on both the sides, what we get is, on the left hand side we have L raised to 1. On the right hand side, if you take L, there is one L raised to x, there's into L raised to y. So it will be L raised to x into L raised to y, which can be written as L raised to x plus y, isn't it? Now this exponent of L on the right hand side, you compare with the exponent of L on the left hand side. So on the left hand side, you have exponent of L as 1. So for L, if you compare the exponents, you will get 1 equal to x plus y. Okay. Same way, if you compare the exponents of m, here you don't have any m. Okay, so m raised to 0. So the exponent of m will be 0. Okay, and here you have m raised to x. Okay, so exponent of m is x, right? So 0 will be equal to x, and you have this m raised to z also. On the right hand side, you have m raised to x times m raised to z. So this can be written as m raised to x plus z. So on the right hand side, the exponent of m is x plus z. So 0 equal to x plus z. Similarly, for t, you will have minus 1 equal to minus 2x. Okay. Now, these three equations, if you look at these three equations carefully, from here you will get x equal to 1 by 2. Okay. Now, that if you substitute over here, you will get z equal to minus 1 by 2. And that if you substitute over here, okay, you will get y is equal to 1 by 2. So you get x equal to 1 by 2, y equal to 1 by 2, and z equal to minus 1 by 2. So this formula will now work out to v is equal to constant k you keep as it is. Now this is f raised to x. X is root raised to 1 by 2. Okay. So this will be f raised to 1 by 2. This L will be raised to 1 by 2 because y is also 1 by 2. Z is minus 1 by 2. So m raised to minus 1 by 2, right? So 1 by 2, anything raised to 1 by 2, like f raised to 1 by 2, can be written as root of f. Okay. And L raised to 1 by 2 can be written as root of L, isn't it? And same way, m raised to minus 1 by 2 can be written as 1 upon root m. Okay. Now, if you club this together, half f raised to half into L raised to y into m raised to z. If you do this, you will get square root of fl upon m. This is the formula that you will get. Okay. So, this is one important thing that you understand in physics. Now, some important order of magnitudes. Okay. Some important order of magnitudes of mass, length, and time I have discussed here. So I'll quickly go through it. Mass, the order of magnitude of the uh, mass of the universe is 10 raised to 53. Mass of the Milky Way galaxy is 10 raised to 41. These are the order of magnitudes, right? In kg. And mass of the sun 10 raised to 30 kg. Mass of the earth 10 raised to 24 kg. Aeroplane 10 raised to 3 kg. Apple 0.25 kg. Okay. Raindrop 10 raised to minus 6 kg. Hydrogen atom 10 raised to minus 27 kg. Electron, mass of one electron is 10 raised to minus 30 kg. These are the order of magnitude of certain quantities. Okay. Now let us try to find out the order of magnitude of length in meters. So edge of the observable universe is 10 raised to 26 meter. This is the order of magnitude of the edge of the observable universe, okay, in meters. Then Andromeda, Andromeda galaxy. Now Andromeda galaxy is the nearest galaxy to our Milky Way galaxy, okay, and this the length of this particular Andromeda galaxy from our galaxy is 10 raised to 22 meters. Diameter of the Milky Way is 10 raised to 21 meter. Distance of the nearest star is 10 raised to 16 meter. Diameter of our solar system is 10 raised to 13 meter. Distance of the sun from the earth is 10 raised to 11 meter. Radius of the earth 10 raised to 7 meter. Size of the cell 10 raised to minus 5 meter. Size of the hydrogen atom 10 raised to minus 10 meter. So these are the order of magnitude. Now let us try to see what are the order of magnitude of the time. Okay. So age of the universe 10 raised to 17 second. Age of the earth same as age of the universe 10 raised to 17 second. Light travel, the travel time of the light from nearby star to earth. So suppose there is a nearby star and from there the light has to reach earth. So what is the time? So it is 10 raised to 8 second. Okay. 10 raised to 8 second. In 1 year, the time is 10 is to 7 second. In 1 day, 10 is to 5 second. Heartbeat, human heartbeat is 1 second. Periodic time of the red light, or the time period of the red light is 10 is to minus 15 second. And time to pass across the nucleus for the light. Okay, so if you if you want to pass the light across a nucleus, okay, it will be 10 is to minus 424 seconds. 10 is to minus 24 seconds is a very small unit. 10 is to 17 is a very big unit. Okay. So with this, we come to an end, or before that we come to an end, let me tell you about this also. In physics, you can come across three fundamental interactions. One is the gravitational force interaction. Second is something called electroweak interaction. In this electroweak interaction, you have electromagnetic plus the nuclear forces ka reaction, okay, interaction. This nuclear force interactions are taken as weak force interaction. Okay. And the third one is something called color interaction or strong nuclear force interaction. Now, these are the things which you will study further in your physics when you go to a higher level, maybe in the 12th grade. You'll understand all these concepts of fundamental interactions in physics. So, basically, remember there are three fundamental interactions: gravitational, electroweak, and color. Now, what are Fermi problems? These Fermi problems are problems based on the order of magnitude that we started with. Okay, this session we started with order of magnitude. On the concept of this order of magnitude, there are so many interesting problems like what is the speed with which the human hair grows? Now, somebody asks you to find out what is the order of magnitude of the speed of the growth of the human hair. Okay, then these are the problems which are called as Fermi problems. Okay, Fermi problems are problems related to order of magnitude. Second one is how many sand grains will fill the earth. Earth is a huge planet. Now suppose you somebody asks you how many sand grains will be required to fill the entire earth. It will be a huge amount, isn't it? So what will be the order of magnitude of that number? Then how many revolutions is made by a car's tire in traveling 250,000 kilometer? Okay, so suppose a car is traveling 250,000 kilometer. How many times the car wheel has made complete rotation, or how many revolutions have been made? So again, it will be a huge number of revolutions. So that all these things, they come under Fermi problems. So in the next session, I will be solving some few Fermi problems with you people. And after doing that, we'll be moving to the chapter number 2 of this IBDP 11th grade physics class session. Okay. So this session I will end here and here itself, and hope that you like this video, you like this session of mine. Okay, and if you have liked it, please subscribe my channel to motivate me to make more and more such videos for you people. Okay, so goodbye, take care all of you, see you.